These are the notes for the second assignment, descriptive statistics calculations. The first page of your third assignment is also the same kind of thing, so you might want to try to do that today also. I'm going to show one of these by hand and then one using Calculator Soup. What a name for a website that does descriptive statistics calculations. So I'm going to be, it's already pre-entered, using that just to quickly get the values for the second column. And then I'm going to show you how to compare skewing of the mean and skewing of the standard deviation, which will demonstrate which set is more skewed and then which set is more dispersed. So watch those calculations as I go. Also, I didn't make them a formal step in this assignment, but you will have it on the quiz, so you might want to do it. And I'll do the skewing calculations up here in these blanks, and then down at the bottom, I'll do the dispersion calculations and what you need to do. It's really very simple. All right, so what is the mean? The mean is the sum over the count. This is something you should know. We did some weighted mean calculations. And the sum of this set with our outliers is 1,049 over 11. And that's 95.4 for the mean of that set of data. Notice how that's kind of low, and it's because of the two tens. The median is going to be 110, and we get this by striking out from the ends and getting to the middle. So there's 3, and then 4, and then 5. So 110 is the middle. Now, before I go any further, notice the mean is to the left of the median. So we call this set of data skewed left. And what we're going to do to get a value to compare to the other set of data is we're going to take the difference, because in a good set of data, the median and the mean should agree. Here they don't. So 14.6 is the difference. And then we're going to divide back by the mean. So the difference between those two divided back by the mean. And that's going to give us a value that we can compare to the second set of data when that comes about for the mean and the median. So there's some skewing going on because of those two tens that's pulling that down the mean. Mode is the most repeated. You can see that it is 110 4 times. The range is the largest minus the smallest, so 129, that's a very big range for this set of data. Lower extreme is the lowest value, upper extreme is the upper value. Now your quartiles, so Q2 is the median, and then Q1 and Q3 are also known as the lower and the upper quartile. How do you get those? You exclude the median position, and then you look at the set of numbers to the left and to the right, and then you do the same thing. You strike out and get to the middle. So strike out 101, strike out 121. So 101 and 121 are the two. Now I need to say this, you need to be very wary of certain sites or certain data calculators. Now Calculator Soup does it the way I showed you. The TI-84 does it the way I showed you. There are many ways of calculating the quartiles. That's one of them. And so you exclude the median position. If there's an even number of data elements, then you have all the data grouped. So there was an odd number here, there's 11, so the middle one's left out. And then you strike out and get to the middle. So it's like saying the median to the left of the median and the median to the right of the median are the quartiles. Interquartile range, subtract Q3 minus Q1. That's what that is. Why do we do that? Because we need it for the calculation for the outliers if there are any. So how do you calculate outliers? It's the lower quartile minus 1.5 times the interquartile range, and the upper quartile plus 1.5 times the interquartile range. And those will be the boundaries or your outlier value. So anything less than 71 and more than 151, you have to apply it back to the set of data. So 10 is going to be an outlier. And that makes sense because the mean is artificially low. Outliers affect the mean and the standard deviation. They also affect the other things, especially the range. So what's affected the most? The range, the mean, and standard deviation are just completely bent out of shape by outliers. Percentile of 110. So you count to the last 110. This is like a ranking of where did you finish relative to everyone else. So it's the last 110 out of the total number of numbers. So 0.73, 73 percentile. If you got a, if your score was 110 and this was a set of scores, you'd be in the 73rd percentile. And then this, you would have to get this from either your calculator or calculator soup. That is the standard deviation. We're also going to divide this by the mean, by 95.4. We're going to come up with a value, and this is a value we're going to use to make a comment on what one of these is more dispersed. So 0.456. That's a huge value. So let me give you an idea of a good set of data. In a good set of data, the standard deviation is 10% of the mean. Here it's 45% of the mean. We got problems. And the problem that we have are those two tens. So now we're going to throw away the two tens. And we're going to do a calculation without the outliers. And I'm just going to go to calculator soup here real quick. They're already entered in. I'm going to press calculate, and it's going to give me all the values I need. So 114.3, and the median is 110. Now we're going to do the same thing we did before. So you got them all. I'm going to come back to my overhead. We're going to do the same thing we did up here. We're going to find the difference, which is 4.3, and we're going to divide by 114.3 to get a skewing value. So this is one on the left, obviously, with the outlier, is skewed way more to the left than this is skewed to the right. This is mildly to the right. And so what's the 139 is pulling a little bit. Once we throw the tens away, it's pulling on the right a little bit. And then the rest of these values, the mode, notice how the range decreases tremendously. And the lower extreme and quartiles are figured the same way. Upper extreme, 139, inner quartile range, 16.5. And so there will be none here. Now, calculator soup, the nice thing is it tells you that there are no outliers. Okay, so you can just put none there. And then percentile for 110. So it's in 6th place now at the end out of 9. And so that is 0.67. So by getting rid of the two low ends, you're going to drop in percentile because you got rid of a score that was worse than you. Standard deviation is 12. Now that's more like it. So 12 out of 114.3 is going to be a little bit over 10%, but this is much better. So 11% compared to 45.6%. So on your quiz, what you're going to have to do, you're going to have to compare these values. This is more dispersed because the standard deviation relative to the mean is huge. Again, 10% is where you want to be typically. So this is not a bad set of data. And then this is more skewed. Now, does it always work that way? The answer is no, but generally it does. So if you have data that's more spread out, it's because outliers are causing maybe that spread. So yeah, they affect the mean tremendously, the range tremendously, and the standard deviation. And once you remove them, you get a much more normal set of data. So that's your notes, and then you have one to do for your assignment.